Welcome to my YouTube channel. This is A Square Maths Made Easy Words Academy. A Square Maths Made Easy Academy. Good morning, good afternoon, and good evening, depending on the location that you are watching. Now, right away, in my today's video, I'm going to consider what we call calculation in calculus, and this is part 1. And most of the things that I want to do is exam tips, exam questions, and this is objective question. Now I'm going to categorize this problem into 2. Number 1 is this. I'm going to use the normal method, especially for those who wants to write on theory questions. Then after that, I will now use the shortcut method for those who are writing CBT or professional exams. Are you ready for that? Now look at this particular question. Now wherever you are, please, if you have not subscribed my YouTube channel before, please subscribe. And after subscription, please comment in the comment section, and also share and like. Thank you so much. One love. So can we get a look at this particular question? Now I want us to go. Now look at the first question here. The first question says, if y is exponential of 2x plus 3 raised to the power of 2. Now the question is find dy dx. Now these are the options. So let's now look at how we can solve this particular question, which is number 1 question. Now the question is given as y equal to exponential 2x plus 3, all raised to the power of 2. Now we are asked to differentiate this. Now I want you to understand this. The process by which can differentiate this is using what we call differentiation by chain rule, or function of function. Now some students may ask, how do we know that this is by chain rule? I want to say something. Now for instance, if you have a single function like this, there is no variable attached before it, or there is no variable attached after it. That thing is differentiation by chain rule. But if I now say x exponential 3x, can you see it is no longer a single word function? This is a product function. X is another of its own. Exponential is also another of its own. So which means this one is multiplied by this. Now this type of differentiation is called differentiation by product rule. But what if peradventure I have something like this? Exponential 3x, then all over x. Can you see that now? It is no longer product, it is no longer chain. We call it differentiation by quotient rule. The word quotient rule means division. So can you see that we have numerator and denominator? You approach it using what we call differentiation by quotient rule. But if I have something like this, 3 exponential 4x, and the question says we should differentiate, it is still by chain rule or function of function, because this is just a constant. Am I communicating? Now let's continue. Now the question is this: what is the formula for differentiation by chain rule? By chain rule. Now this is the formula. The formula says dy all over du dx. Dy all over dx is equal to du over dx multiplied by dy over du. Now, can you observe something here? There is du here, there is du here. When both of them cancel each other, what remains is dy dx. And dy dx to the right corresponds dy dx to the left. And that is why they are in chain. What is on the left is exactly what is on the right. Now, the question is that I'm going to consider any of these functions here to be u. If I'm considering u, which means I'm differentiating u with respect to x. Then if I consider y, I'm going to differentiate y with respect to u. Now, among the exponential and the power, which one am I going to consider as u? U is always the power. Am I communicating now? So let's start with now. I will now say let u be the power. What is the power? 2x plus 3, all in bracket raised to the power of 2. So my target now is to differentiate u with respect to x. I will now have the u all over dx. Are you with me? Now what do you differentiate? How do you differentiate this? Normal differentiation. I want to teach you something. The first thing is to consider the power. What is the power? 2. I will now put down 2. Second thing is to differentiate this base. And this base is 2x plus 3, right? I want to differentiate it normal. This is an invisible what? 1. Now, how do I differentiate 2x? Consider the power. What's the power? 1. Then I will multiply. Then repeat the question. The question is 2x raised to the power of what? 1. And finally, introduce minus 1 to the power. And that is the rule of differentiation. I am done with this. Then I will add. This is a constant. Anytime you are differentiating a constant, the result is always what? 0. Or you neglect it. Then the question, what do you mean by a constant? It is a number that has no variable attached to it. And what is a variable? X, Y, just like that. Now, if I continue, 1 times 2x will give me 2 what? X. Raised to the power of 1 minus 1, what is the answer? 0. This one is already off, right? Then I will now obey the law of indices. The law says anything raised to the power 0 is always what? 1. Which means 2 times 1 will give you 2. Are you with me? So if they ask you now to differentiate 2x, what is the answer? 2. Then if I have something like this, they ask you a question also to differentiate 3x. The answer is what? 3, which is the coefficient of x. If you are given minus 1 over 2x and they ask you to differentiate it, it is the coefficient because the power of x is always 1 here. The answer is still minus 1 over 2. This is how to approach problems like this. Are you with me? It is only applicable when the power of x is what? 1. So let's move now. Now what am I trying to illustrate here? Let's go back to where we are. Now I want to take you a look at this. Back to this differentiation. Consider the power. What's the power? 2. Then I will now open the word bracket. The next thing is to differentiate 2x. I've explained it, which will give us what? 2. This 3 is a constant. Throw it away. Then you close the word bracket. Then after that, what do? Repeat the question. What is the question? 2 what? X plus what? 3. Close the bracket, raise to the power of 2. Then finally introduce minus 1 to the word power. Then, do you get me now? Why? Because differentiation is reduction. So in summary, I will now say du over what? Dx is now equal to 2 times 2 will give us what? 4. Open the bracket. So I have with me here 2x, then plus what? 3. Close the bracket. 2 minus 1 should give you 1. So which means the value for du dx, which is here, du dx is what? 4 bracket 2x plus what? Y plus 3. Then the next thing is to consider y. How do we approach it? I will now say let y be the exponential. This is what we introduce as y, exponential. But to the power should not be u. Do you know why? We are differentiating y with respect to what? U. Then if I differentiate y with respect to u, I'll be having dy all over what? Du. Then this is now equal to. How do I differentiate expo? First of all, you differentiate the power. Am I communicating? Differentiate the word power. What is the power? The power is u. Invisible word 1. Then if I continue, I will consider the power, which is 1. Then I will multiply by u raised to the power of what? 1. And introduce minus 1 to the word power. Then 1 times u will give me u, right? Then 1 minus 1 is what? 0. Then by the law of indices, anything raised to the power 0 should give you 1. So which means if I differentiate u, it will give me what? 1. Then I will multiply. The rule of exponential is that repeat the expo. The expo is exponential u. Repeat. The reason is that expo is what? Expo. And I will show you how we prove this thing in order to arrive at exponential word function in my main lesson. Now what do we do? Can we continue? This is now equal to 1 times exponential u is exponential what? U. So which means we have known dy du. Let's go back to the formula. So the formula is what? Dy over what? Du. Sorry, dx is now equal to, we have du dx. Now look at it, we have solved it. Du dx, what is the result? The result is 4 bracket 2 what? X. Then plus what? 3. Close the word bracket. Then followed by dy du. Look at it, dy du, what is the result? Exponential what? U. Then what do I do next? Finally, I will now consider u. U is already known. Substitute for that. Look at u from the question. This is the value of u. Then I will now summarize it by saying 4 bracket what? 2x plus what? 3. Close the word bracket. Exponential what? U. What is the value of u? U is bracket what? 2x plus what? 3. All raised to the power of what? 2. Now this is the final word answer. Can we now look at the options and know if something like this exists? Option A says 2 brackets no. Option B says 2x plus, no. Option C says 4. What is here 4? What is here 4? Then what is here 2x plus 3 close bracket, 2x plus 3 open and close bracket. What is here? Exponential of what? 2x plus 3 all square. Then what is here? Exponential 2x plus 3 all one square. So which means the correct answer in the option is option what? C. Am I communicating? Now this is just how to solve it using what we call normal method, which is the formula. But can I shock you that you can use just a second or a minute rather to get this answer and just check the correct one? I want to show you. That one is called shortcut method. So let us look at how we can generate this answer, our question, using shortcut what? Method. Are you with me? Now, I want to clarify something here. It is very simple. Permit me to give you the steps that is guiding it. Are you with me? Now, the first step you are going to approach now is to consider the power. Consider what? The power. The power outside the bracket. Outside the what? Bracket. That is the first thing. Consider the power outside the bracket. The power outside the bracket is 2. Are you there? Then after that, you now differentiate the one inside the bracket. Differentiate what? 1 inside what? Bracket. That is the second step. Then the third step is to repeat. Are you with me? Is to repeat the bracket. Repeat what? The bracket. And introduce -1 to the what? Power. Are you with me? And then simplify. Then the fourth one is this. You should now repeat. What did I say? Repeat the word exponential. Repeat the word exponential and simplify. And do what? Simplify. And that is the final word answer. Now let's get back to the question now. The question says that y is now equal to exponential of what? 2x plus 3 all raised to the power of what? 2. Now what are we trying to differentiate? Y with respect to what? X. It will give us the y all over what? The x. Are you with me? Then this is now equal to. The first thing is to consider the power outside the bracket. Look at it. The power outside the bracket is 2. Then write 2. Open the bracket. The second step is to differentiate 1 inside the bracket. The 1 inside the bracket is 2x plus what? 3. Can we differentiate? I have taught you. If they ask you to differentiate 2x, what is the answer? 2. This is a constant. Throw it what? Away. So which means if I differentiate the 1 inside the bracket, the only result is what? 2. Then close the what? Bracket. Then the third step is to repeat the bracket. What is the bracket? It is bracket 2 what? X plus what? 3 raised to the power of what? 2. And introduce -1 to the power. -1 to the what? Power. That is the third step. Are you with me? Then what should be the first step? Repeat the exponential. This is the exponential, which is what? Exponential what? 2x plus what? 3 raised to the power of what? 2. Let's get the final answer. Now 2 times 2 will give us what? 4. Are you with me now? Then you now open the bracket. This is 2x plus what? 3. Close the bracket. What is 2 minus 1 is 1. Then exponential of what? 2x plus 3 all raised to the power of 2. And that is the final word answer. Can you see that it is exactly on the one we use and also the shortcut? So the correct answer in the option is option word C. Have I made myself clear? Now let's move quickly to the second word question. Now, the second question is this, number 2. I want you to watch. Number 2 says, we should find the domain and range of f. Sorry, the domain and range of f is dash and dash. And this is the function f of x is equal to square root of x minus what? 1. Now, these are the options. Am I communicating? How do we approach this? I want you to watch. We have what we call f of what? X. Then this is now square root of what? X minus 1. Now listen carefully, everyone. I don't need to go far in order to identify the domain of this very particular word function. All you need to do is very simple. Now this f of x means function of x, and it can be represented by letter what? Y. So which means y is square root of what? X minus 1. So when we discover the domain, we can know the word range. The range is y, and the domain is set of what? X. While the range is set of what? Y. How do we discover this? We first of all use x to determine it. Am I communicating? There is what we call real numbers. And real numbers are what? Minus infinity plus what? Plus infinity. Like this. This is how to represent it. And this is how to determine the domain and range of a particular word function, depending on the nature of the word question. Then my question is this. You should be able to agree with me that for this function to exist, since the value here, a constant here, is 1, it implies that the minimum value of the domain is that x should be what? 1. I mean the minimum value. And what you should observe here is that for the domain to exist, it must increase. It must what? Increase. It will not decrease. So I said since here is 1, with this I have already located the word, the domain. So which means the least value of x here is what? 1. How? Now by the time I figure out to put x as 1 here, it will give me a result. But when I consider x to be 0, look at it now. It will become square root of what is x? 0 minus 1. Then become square root of 0 minus 1 will give you minus what? 1. And square root of 1 does not what? Exist. So any value that is less than 1, as far as this particular function does not exist as what? The domain. But any value that starts with 1 and above exists as what? Domain. Am I communicating? I have used an example. So which means the minimum value of, since there is 1 here, the minimum value of s for this thing to exist is when s is 1. Now let's solve it and know the range now. I will now say that y is now equal to square root of what is x? 1 minus 1. Are you with me? So if you continue to become square root of 1 minus 1 is what? 0. And what is square root of 0 is what? 0. Now it will increase to when x is what? 2. I will still get the range that y is now equal to square root of what is x? X is 2 minus 1. Now what is 2 minus 1? It is 1, right? I will now say square root of 1. And what is square root of 1? 1. With this, I don't need to continue. I've already observed my domain and also the word range. But let's add when x is what? 3. So let's go back again. This is y, right? Then equal to square root of what is x? X is what? 3 minus 1, which will give me square root of 3 minus 1 is 2. And what is square root of 2? 1.414. Then with this, I've known my range and my domain. Now what I'm going to consider now is domain. Is what? Domain and what? Range. With this, I will calculate for it. What are the values for domain? The least value there is when x is what? 1. It increases to what? 2. It increases to what? 3. And since it's increasing, my question is this. What is the word increase? Is it negative infinity or positive word infinity? Anytime you hear the word increase, it is positive word infinity. So which means this value is tending to positive word infinity. Am I communicating now? Then we now move to the result of the function. The first range when s is 1 is what? 0. When s is 2, what is the answer? 1. When x is what? 3, what is the answer? 1.414. Are you there? Now observe the range. Is it increasing or decreasing? I believe from 0 to 1, from 1 to 1.4, it is what? Increasing as well. Why is it increasing to positive what? Infinity. Are you with me now? Now, but the minimum value of the range is what? 0. How do we now consider the domain and the word range? With this diagram now, it is obvious that the answer is already there. Can we now go? Now, which means the domain now, which I will say domain of f, is now equal to, what's the minimum value? The minimum value is what? 1. Use block, because 1 is a member. And it's tending to what? Positive what? Infinity. Infinity is always bracket. Am I communicating now? Then the next thing is range of what? F. The minimum value is what? 0. I will not use block because 0 is a member. Tending to where? positive what? Infinity. Use what? Bracket. Now the answer is this. Am I communicating? Let us observe this in the question. Now the first option says block 1 comma plus infinity, yes, but this thing has disqualified it. No. This is domain and this is range. No. Now observe this block 1 comma plus infinity, then comma block 0. Block what? 0 plus what? Infinity. The correct answer now is option what? C. Am I communicating? Now, if you cannot observe this, another way that you can satisfy this particular problem is this. Look up. I can now say X is a set of X such that X, are you with me now, is a member of what? Real number. Am I communicating? Such that what? X is what? Greater than or equal to what? 1. Now, this is another way. Can you see that X is greater than or equal to 1? It's the same thing like this. Am I communicating now? Then we now move again to range. Range is Y. What did I say? Y is such that Y is a member of what? Real number. Such that, what is this? Change 0. I will now say that Y is greater than or equal to 0. Do you know why I say greater than or equal? Because it's tending to positive what? Infinity. Now, can we look at the last question? The last word question. What did I say? The last word question. Now, let us look at the last question and cut it off. So that is the how to identify it. Question number 3, which is the last word question. Now observe this. The last word question. Now look at the last question. Evaluate integral of what? This is number 3. Integral, which is the last question. Integral of 2x exponential what? 3x under what? Dx. Now this is the last question for today. Now, what am I trying to tell you here? There is what we call integration by parts and integration by substitution method. Now, what is integration by substitution method? Now, if you differentiate this 3x, it will give you over what? 3. Can you see that there is no x again that can vanish this? So, which means this thing cannot go by what? Substitution. I'll still teach you. What do? We use what we call integration by what? Part. But there is a shortcut of approaching this using what we call using DI what method. What did I say? DI what method. D means differentiation and I means what? Integration. How? I'm going to present it like this is D and this is what? I. D means differentiation. I means what? Integration. Now, which among these that will differentiate easily at the end x will vanish? It is 2 what? X. So which means I will consider 2x as differentiation. While the other one, which is exponential, I will consider it as integration. Do you know why? If I differentiate expo, it will keep on reoccurring. If I integrate expo, it also keep on what? Reoccurring. But the only variable here that we can integrate and at the end it will not later change to 0 is 2 what? X. That is why I gave it D. Then let's start now. Now what do? Differentiate 2x, I've taught you, it will give you 2, right? Then how do we differentiate, integrate exponential? Listen, this is the law. First of all, repeat the question, which is exponential 3 what? X. Under integration, introduce over. Introduce what? Over. And differentiate this 3x. What will be the answer? 3. So this 3 will come down. But if it is differentiation, the answer would have been differentiate 3x. It will give you 3. Then repeat the exponent, which is 3x. This is called differentiation. But integration is exponential 3x all over 3. Do you understand? Then let's continue. Differentiate a constant. What is the answer? 0. Can you see? I will stop here. Then integrate this. Repeat exponential 3 what? X over. What do? Differentiate this 3x. It will give you 3, right? Use that 3 to multiply this 3. What will it give you? 9. I'm done with it. So what do? Begin to analyze it. It is constant. The first one is plus. The second one should be minus. The third one should be plus. And if we have another one again, it would have been what? Minus. Then finally, can we say that integral of what? 2x exponential what? 3x under what? The x is now equal to, now watch this. Now let's go. This is how we approach it using slanty form like this. This is how it goes only. This one and this one is irrelevant. I will now say 2x times this will give me 2x exponential 3x divided by what? 3. Are you with me? Then what do we have here? Minus. Then 2 times this will give me 2 exponential 3x divided by what? 9. Then finally, you put plus c. The reason is because this type of integration is indefinite. It has no bounded upper limit and lower limit. Can you observe that I've gotten it already? What do? I can factorize. There is what? 2 here. There is what? 2 here. Are you with me now? So what am I going to do? I'll factor 2. What it can go? 3 can go, 3 can go. Then over what? 3. Are you there? Now there is expo. There is also expo. I will now say exponential 3x. Open the bracket. By the time 2 go with 2, expo go with expo, what remains there is x over. Now this divide this is 1 already here. Are you with me? Then you now say only x minus 2 go with 2, expo go with expo. It becomes what? 1 all over. 3 can go into now how many times? 3 times. Close the bracket. Then plus what? C. This is the final what? Answer. Now do we have something like that in the option? Let's observe this. Exponential 3x over 3. No. Then let's have this 2 exponential 3x over 3 bracket what? X minus 3. Then plus what? C. Wow, the correct answer here is option what? B. That is how to solve problems like this using what we call DI what method. Do you understand? But to use what we call integration by what? By what? Parts. Which is the normal formula, which is the final one for my video. How do you approach this problem using what we call integration by what? Parts. Are you with me? Now I want you to watch. Using the normal method, which is called using what? Integration by what? Parts. Integration by parts. I will tell you the reason why we should use most of it in my main lesson. But I want you to appreciate something here. What is the formula for integration by part? Look up. Integral of u dv over what? dx is now equal to uv minus integral of what? v du all over what? dx. Are you with me now? Now the question is this. Now I want you to observe something here. Which one is differentiation? The first one, call it u. The one integration, call it what? dv over what? dx. Life goes on. So which means we start with let u be what? 2x. Are you with me? Then what are we going to do? Differentiate u with respect to what? X. It will now give me du all over what? dx. I have always said if you are given 2x to differentiate, the answer is 2. So which means the value of du dx is 2. Du dx is already what? 2. Now the next thing we are going to do is say let dv over what? dx be what? Exponential 3 what? X. What is my target now? Call this over 1 and cross multiply. Now this implies dv times 1 will give you what? dv. Then equal to the x times exponential is exponential 3x what? dx. Am I communicating? Can you see I have separated them? What next? Integrate both sides of the equation. Both sides of what? The equation. Then let's continue. Integrate dv. It will now give us v. I will tell you the reason. Am I communicating in my main lesson? Now what do we do? Then integrate exponential 3x. Expo is what? Expo, I've told you. Then divide because it's integration. Next is to differentiate this 3x. It will give you what? 3 at the denominator. With this now we can substitute. So this is the question. Integral of u is already 2x, which is the question. Now dv dx is what? Exponential 3x. Which is under the x equal to. Then u, what is u? U is 2 what? X. Close the bracket. Then what is v? Look at v. V is exponential 3x all over what? 3. Then what is here? Minus integral of, what is v? V is what? Exponential 3x all over what? 3 times du dx. What is du dx? Du dx is 2. Now remember to put the x because we still have an integral remaining. Now what is the next thing? Watch. It will now give you 2x times this will give you 2x exponential 3 what? X divided by what? 3. Now what do you do? Factor the values out. This is minus, right? Factor 2 out. Then over. Factor 3 what? Out. And integrate expo only. I've taught you how to integrate expo. Expo is still exponential what? 3x over differentiate 3x. It will give you 3. Bring it down. Finally plus what? C. Can we continue? This is now 2x exponential what? 3x all over what? 3. Then minus what? 2 times expo is 2 exponential 3x all over. 3 times 3 will give you 9. Then plus c. Wow. Can you see that we have already gotten what we are looking for? This is the normal method, which is called integration by what? Part. At this junction, I will now factorize. Watch. There is 2, there is 2. There is expo, there is expo. You have 2 exponential 3x. Then over. 3 can go, 3 can go. Then put 3 and open the bracket. By the time 2 go with 2, expo go with expo, what remains there is what? X. Then I have with me minus, right? Then next one, 2 go with 2, expo go with us, remain what? 1 over. Now watch this now. 3 go inside is 1, then it becomes over 1, which is still x. But 3 can go into now how many times? 3 times. Then close the bracket plus what? C. Can you see that it has correspond using what we call DI what method? Do you understand? Now this is A Square Maths Made Easy Academy. See you in my next video when I'll be talking more problems on calculus. Calculation in what? Calculus. Please subscribe, comment, share, and what? Like. See you.